Morning students, welcome to today's class. uh, Hope you are doing your lessons properly. You understood the previous lessons properly, and you are doing your worksheets regularly. You are solving the worksheets regularly. Do that. Okay. Today we will continue with chapter 3 only, and we will discuss separation techniques. So let's start. Today our points to be discussed will be separation of solid liquid mixtures and separation of liquid liquid mixtures. So separation of, first we will do separation of solid liquid mixtures, sedimentation and decantation. So this process we will be using for separating, suppose, sand and water mixture or muddy water, uh, where the particles, solid particles, are heavy in weight. So as they are heavy in weight, so due to gravitational force, due to gravity, they will come down, they will settle down. You can see in the beaker, this is the liquid, and here at down you can see the sediment, that is sand. As sand particles are heavy in weight, so they will settle down, they settle down at the bottom, and then this process is called sedimentation. This sedimentation process we can make faster. We can fasten the process by using different chemicals like alum. Alum is a it's a chemical which we can use to increase the rate of the sedimentation. Okay, so after that, after getting the sediment, we need to separate the liquid and the sediment. Okay, so for this process we will be using the decantation process to separate these two. So without disturbing the sediment, slowly we will transfer the liquid. This liquid is called supernatant liquid. Okay, the liquid above the sediment, this is called supernatant liquid. This we will be transferring to another beaker using this glass rod. Okay, so this sediment, this will be there only in the first beaker, and the supernatant liquid, that can be transferred in this another beaker. This whole process is called decantation. So by sedimentation and decantation process we can separate heavy, solid and liquid mixture. So where one of the component, means the particles, solid particles, are heavy in weight, so for those substances we can heavy in weight, and that must be insoluble in that particular liquid. So for those mixtures we can use this process. Next, filtration process. This process we can use for both heavy particles and the particles which are light in weight, but in both the cases the particles, solid particles, would be insoluble in that particular solvent. Okay, so here we have taken the filter paper. This filter paper will be placed in the funnel, and then in this beaker we will be taking the mixture of solid and liquid mixture, and then we will pour the mixture, the whole solution, in this filter paper. The residue or the solid particles, they will be left behind in this filter paper, as they cannot pass through the holes, fine holes of the filter paper, but the water, as they can come across the filter paper, so they can get collected in the conical flask as filtrate. So filtration process we can use for separating a solid liquid mixture. Okay, here this process we can use for separating chalk and water mixture, chalk dust or calcium carbonate and water mixture, or husk and water mixture, or sand and water mixture also we can use this process. Next, evaporation process. This process we can use for separating substances which are soluble in water, like salt and water or sugar and water. So in this process we will be taking the whole solution in the evaporating dish. You can see the dish, and this we will be placing on the stand, and we will be heating this. The water part, this will evaporate, and the water part will evaporate, but the salt will remain in the evaporating dish. When all the water will convert to water vapor, we can get back the salt in the evaporating dish. So in this process, by this process we can separate sugar and water or salt and water, these mixtures which are soluble in water. Next, crystallization process. This is another process which we can use to separate soluble solid liquid mixture. The substances, the particles or the solutes which are soluble in water, that can be separated in this manner. So for crystallization process, what we will do, first of all we will take the solution, the soluble solution, the soluble particles which are soluble in water, the particles which are soluble in water, that we will make it soluble in the beaker, and we will make a hot solution, so that maximum solute will dissolve in the water, in the solvent, so that we can get a saturated solution. Now we will uh, pass the we will pass the solution through the filter paper. We will filter it, and as the filtrate we will get the saturated solution, and if anything will be unsoluble there, that will remain that will be staying back in the filter paper. Now we will work with the filtrate. The filtrate we will cool down, or we can keep it in open in room temperature also, for but that will take some time. That will take maybe 1 day or more than 1 day sometime. So slowly this when the solution will cool down, the filtrate will cool down, the particles or the particles will come out from the filtrate as crystals. Crystals, you know, these are the particles, solid particles having regular shape and size and having sharp edges. So these crystals of soluble solid that will come out from the solution, and we can get the pure form of the solute, pure form of the solid substance which will be which are there in the solution. Okay, so this process is called crystallization, as we are getting crystals after the process. Next, come to distillation process. This process is again we can use for the substance, for the mixture where the solute particle is soluble in water, soluble in the solvent. So for salt and water solution, we can salt and water mixture, we can use this distillation process. Here just in the container we will be heating the solution. This is the Bunsen burner. We will be heating the solution, and this salt part, as the salt part will remain in the container, remain in the round bottom flask, but the water part will evaporate, and that water will after forming the water vapor, this vapor will comes through the this vapor will come through this pipe, through this tube, delivery tube we can say, and this will be fitted with the condenser. This is called Liebig condenser, and here it will condense, and we will get the water part, means the water vapor will cool down, it will condense, and we will be getting the it will convert to water again, and that can be collected in this conical flask. So the salt will remain in this container, remain in the round bottom flask, and we will be getting the water in this conical flask. So both can be separated and collected through this process. This process is called distillation. Next, centrifugation. This process again we can use for the separating the particles from blood, or separating cream from milk, like this. So centrifugation is what? Here we will be using the apparatus, this is called centrifuge, and there with a high speed the mixture will rotate. Okay, this process is called centrifugation. This we can see in washing machine as also. So when it will rotate in a very high speed, then the solid particles, means the particles which are heavy in weight, that will settle down at the bottom, that will settle down at the bottom like this. Here you can see the blood particles like RBC, WBC, these are heavy in weight, so they will settle down at the bottom of the test tube. But the plasma part, that is light in weight, so that will form the upper layer, top layer of the solution. So here plasma and blood cells can be separated in this manner. The same thing we can use, the churner is there, that is very common thing which we generally use at our home to separate cream from milk. So churner is, again here also we are using the centrifugation, this technique only. Okay, so here in during separation of milk, during separation of the cream from milk, we are using the same technique. As the cream is light in weight, so that will come above, that will form the upper layer or top layer, and the watery part of the milk, that will settle down at the bottom, as it is heavy in weight. So centrifugation is another technique where we can separate the solid and liquid mixture. The lighter particles that will float on the, or that will come up the on the upper layer, and the heavy particles that will settle down. Next, separation of liquid mixture. So there are two types of liquid mixtures. One is miscible mixture, another is immiscible mixture. Miscible mixtures are those mixtures which are both are liquid, but one is both the liquids can form a homogeneous mixture, we can say. We cannot see the particles separately, both will get mixed properly homogeneously. So miscible mixtures, their example you can give as water and alcohol. This will form a miscible mixture, whereas immiscible mixtures are just opposite to that. That is water and oil. That means oil and water cannot mix together, they will form two separate layers. So immiscible mixtures are heterogeneous mixture, where the liquid, both the liquids are immiscible, they cannot mix together, and we can see them separately. We can get to separate layers of the mixtures of the uh, of the water and oil, or the two liquids will form two separate layers. Separating funnel, this we will use to separate immiscible mixture, immiscible liquid mixture. See here, you can see in the figure the low density liquid. Suppose if we take oil and water mixture, if we take, then oil, as it is its density is low than water, then it will form the upper layer, and as water is having high density liquid, so it will form the lower layer in the separating funnel. So this part, this layer is of oil layer and this one is water. So through the, if we open this through this tap, the water will come down. This we can collect in another container, and the low density liquid, for this example oil, this will remain in the separating funnel. So in this manner we can separate oil and water. Next, fractional distillation. This process we will be using for the liquid-liquid mixture which are miscible. Miscible liquid-liquid mixture, in this manner we can separate. Like in crude oil, many oils and many substances are there which are miscible. So for separate those, we have to use this fractional distillation technique. So this is what, uh, as the different liquids having different boiling point, so that this property we will be using for this for separating these components of crude oil. Here you can see gasoline. uh, this will vaporize at 150 degree centigrade temperature. So when we will be heating the mixture, heating the crude oil at 150 degree centigrade temperature, gasoline will vaporize first and then it will condense and that can be collected. And after that, if we continue this heating process, then at 200 degree centigrade temperature, kerosene will vaporize and again it will condense. So in this manner, one by one we can get the different components from the crude oil. Diesel will vaporize at 300 degree centigrade temperature. Fuel oil, that will at near about 370 degree centigrade temperature it will vaporize, and it will, after that it will condense. So in this manner we can separate different components of crude oil. So fractional distillation, this process can be used to separate the miscible mixture where there will be difference in their boiling points. Suppose oil and alcohol and water, alcohol and water can be separated in this manner, as these are miscible liquids. For this fractional distillation we will be using to separate miscible liquids. So oil and water, alcohol and water, these two can be uh, separated in this manner. Alcohol's boiling point is near about 78 degrees centigrade, whereas water's boiling point is 100 degrees centigrade, pure water. So when we will be heating the substance, heating the mixture, at first alcohol will vaporize and it will condense. We can use the distillation technique, means we can use the condenser to condense the alcohol, and water will remain in the container only because it has not reached its boiling point then. So 100 degrees, at 100 degrees centigrade it will reach it to its boiling point, so it will remain back in the container, but alcohol will vaporize. So in this manner we can separate oil and alcohol, any miscible liquid. Next, chromatography. uh, in this process we can separate those substances, those miscible, those liquid mixture which are very whose physical properties, whose properties are very similar. So chromatography technique is the latest technique by which we can separate this, like the constituents of a dye. Okay, so, or ink is a very common example for this. So here you can see, as the ink spot we will be taking in our paper, and as the absorption, this here we will just dip it. The paper will be dipped in the water, which can be used as a solvent. So the paper will absorb the water, but the component of the ink that cannot absorb the water evenly. Okay, and so they will form the spots in different places of the paper. Here you can see the velocity of the spots, the velocity or the absorption rate of absorption, we will say, that is different for different constituents, different components of the mixture. So they will form the spots in different places. The spot or the component which will absorb, the rate of absorption is maximum for the substance, that will form the topmost spot here, and the substance whose rate of absorption is less, that will form this spot. Okay, that means it cannot go much, it cannot rise much, this spot. So accordingly other substances also form the spots. So this is called paper chromatography. This technique we can use to separate different constituent from dye, or if we want to separate the separate drug from blood, that also can be used, that also can be done using this chromatography technique, this paper chromatography. Okay, so this is all for today. Now we will be doing the worksheet, we will be discussing the worksheet, but before that you just pause the video here and bring a pen and paper, and before that you go through the study material also, just see whether you can understand or not, then come back to do the this worksheet. We will be discussing the worksheet which was given in our last class, in our previous class. Okay, so let's do that. See, this worksheet was given. First question was, what is mixture and what are the characteristics of mixture? So this can be written of your own. You can write this, that what is mixture and what are the characteristics of mixture, that is there in the study material only. So you can write your own, I hope. So definition you will be writing and the characteristics of mixture point wise. Okay, next write two examples for each homogeneous and heterogeneous mixtures respectively. So two examples for homogeneous mixture. Homogeneous mixture example can be given as salt and water, or sugar and water, oil, alcohol and water, also homogeneous mixture. So any two example you can write for this. Heterogeneous mixture you can write as sand and water, muddy water can be written, stone and sand can be written, or rice and pearls, that is also a heterogeneous mixture. Oil and water can be written as a heterogeneous mixture. Okay, so any two example you give. Next, differences between compounds and a mixture, that also can be written of your own, you can write your own. Okay, next, what is the purpose of separation of mixtures? Why we need to separate the mixture? Two are there. One is to get the separate the unwanted substances or harmful substances, and to get the useful substances. So these two are the purpose of separation of mixtures. Okay, next, write the separation process to separate the solid mixtures. Number one is sand and iodine. So for this process we have to use sublimation, as iodine can show sublimation. Okay, next, table salt and potassium nitrate. For this process we have to use this as potassium nitrate, that will be showing its fractional crystallization process we have to use for this. as it's much more soluble than table salt, so fractional crystallization is the process to separate these two. Next, husk and grain, that can be separated using winnowing process. As husk is light in weight, so husk and grain that can be separated by winnowing process. So what are the process? First one, sand and iodine for this sublimation. Next, table salt and potassium nitrate for this fractional crystallization, and for husk and grain, winnowing. So these three are the process. Okay, so this is all for today, children. You just go through the study material properly. You just and do the worksheets regularly. I know you are doing, and so this is all for today. We will be meeting in the next class. So till then, stay safe, take care of you, and study properly. Okay, bye bye. Thank you.